Hello, everyone. Today I'm going to introduce a bit about our department, the Department of Applied Mathematics at Chung University, Christian University. So we will just abbreviate our department as CYCU Math. Okay. So before we start, I would like to introduce myself a little bit. My name is Wan-Yu Tsai. I'm currently an assistant professor at CYCU Math. I got my bachelor's and master's degree in mathematics from National Taiwan University, and I also majored in mathematics for PhD from the US, the University of Maryland at College Park. My research field is algebra if you talk about a bigger sense, and more precisely, the research area is representation theory of Lie groups, or I also work on some number theory. And my email address is here. If you have any question, you may feel free to ask me through the email. All right. And here, the first picture here is a science building that I took a few days ago. So this is a science building where the department is located at, and it's not just for math, as it is it's also for physics and chemistry, so psychology, bioscience, and the science faculty is also here. So I took another picture from distance. This one might look better. Okay, here I show you another picture. This is taken from top of the science building, and you can see this very nice view, very nice scenery from the science building. And this is actually just right outside of my office, and I got very lucky to have this great environment to work in. Right. All right. So let me give you a little bit outline of the talk for today. And so I divide this talk into 4 parts. The first part is the introduction, a brief introduction to our department. And the second part, I would like to go into a little bit details about our course map, or say course design. So I'm going to introduce the courses that our department is offering, okay, for the students. And the third part, I'm going to introduce a little bit about our faculty members and their research fields. And the last part maybe is the most important part for students, is about their career developments. All right. And we would like to start with the following question before we give the introduction. So why is CYCU Math different? Why do you need to choose our department, not other departments? Okay. And the main reason is stated here. Compared to other traditional math departments, we have 3 different programs. And here are the list. The listed things are the 3 programs at our department. The first one is the Mathematics and Scientific Computing program. The second one, Statistics and Big Data program. The third one, Computer Science and Artificial Intelligence program. So you might notice that we emphasize a lot on the applied aspects. And how does this work? Okay. Let's specify a little bit about how does this work. So for undergraduate students, in the first year, everybody taking common fundamental math courses like calculus, linear algebra, introduction to computers, and basically most of the students who major in basic science or engineers need to take all of these courses, not just for math students. So there is not too much difference at this stage. In the second years, we usually ask students to choose one of the 3 programs to study, and this is to get more specialized and more disciplined at certain field. Okay. And here we put 2 remarks here, and the first one is that, of course, choosing one program is not mandatory. If once the student don't want to choose one, that is also okay. And another remark here is that you can always switch to another program. So for example, you can switch to another program in the 2nd semester during your 2nd year, if you find another program more interesting or more suitable for you. But we strongly encourage students to choose one program to major in, because we have a lot of advantages about that. Okay, for example, I list three of them. So for example, the first one, if you finish one program, you can get certificate of that program. And actually, some companies take your certificate into account because they know more specific about what you have learned if you get a certificate, right? And a minor advantage is here is that you will have the priority to select the specialized courses of that program if you belong to a program. And another advantage here is that you will be more encouraged to consider your future career. So if you choose one program to be more specialized, maybe you can concentrate more on thinking about how to develop yourself, how to develop your career. Okay. All right, now I'm going to say a few words about the main focuses and developments of our department. So there are 2 aspects here. The first one is about interdisciplinary learning. Okay, so the subject that the student learns should cross a lot of different areas. And the second one is that the innovative implementation. Okay, so these are very practical parts. Okay. So that means in our department, we are not just focused on theoretical aspects. We establish students the mathematical background to make them strong. Okay. But then eventually, we hope the student can put them into practice. So the areas that students usually cross are so many areas like financial mathematics, artificial intelligence, bioinformatics, computer science, medical statistics, data analysis. And so we especially emphasize on these aspects here that will be our future focuses. Okay, the big data, AI, and bioinformatics, quantum computing. Now I'm going to introduce the public area of our department. Our department has very nice and friendly environment for students, and it is actually fully equipped with some software and hardware. All right. So here in this first picture, you can see the discussion room for the students. And the second picture, here is a computer room. And the third picture, it is a library, which has a storage of math books and journals. And now let's look at the next video. So first I'm going to introduce this library. So this is a library and also discussion room where students are working hard, and some of them are resting, and very nice environment. So now I'm going to show you this big computer room in our department. You can see we have 70 computers and plenty of mathematical softwares here. And in fact, a lot of math courses are offered in this room, very well equipped. Now I'm going to show you this new established laboratory. So this is a laboratory of intelligent computing and big data analysis. So let's see. And you can see in here, we have a supercomputer which can compute huge data. And we have some extra spaces here for people to work inside. Very nice.
For the second part of the talk, we introduce the courses offered in our department. Hopefully, this can give some ideas of how our courses are designed. So here is a general picture that demonstrates the number of credits that one should complete in order to get a bachelor degree from our university. So the total number is 128. Here we have some general courses that all students in the university should take, no matter which department you belong to. So let me circle out. These are the general courses. Okay, so we have basic knowledge courses, general education courses. So some are compulsory, some are elective. So these general courses are including the English courses, maybe some Chinese courses, and some general education courses that you can choose. But today, I'm just going to focus on these two parts. So these two parts are the courses offered by our department. So we have required subjects, 48 credits, and the department elective subjects, at least 30 credits. Okay, let's see. So there are, like just mentioned, there are 48 credits of our department required courses that the students should complete. And as I said in the beginning, we have 3 programs. But no matter what program students choose, they should complete all of these 48 credits. And the courses in the first year are very elementary, so like calculus, linear algebra, basic mathematics, introduction to computer, general physics. So these courses are usually taken by basic science students and engineering students. These are not just for mathematics students. Okay. And going into the second year, the difference starts to appear. Okay, we have probability statistics and mathematical software. So these courses are not usually offered by traditional mathematics department. Like, for example, I was a math major from a more traditional math department when I was in college. I didn't take these courses in my sophomore year. Okay. So the aim of these 3 courses is to make students touch more and more different fields, various fields, and make them aware of how to put the mathematical background into practice. And also, you can see in the third year, we have computational mathematics. This is also have some M. Okay. And in the fourth year, we have this mathematics and its applications. So this is just a summary course of all of the courses that the students have learned throughout the 4 years. And this is just a very quick introduction to our required courses. We also offered a lot of elective courses, and I will discuss the elective courses program by program. And here is just a reminder of what our 3 programs are. We have mathematics and scientific computing program, statistics and big data, and computer science and AI program. And let's go to see their elective courses in details. Let's first look at the course map of mathematics and scientific computing program. Before we start, we would like to indicate that the boxes in yellow are the departmental required subjects. The boxes in orange, in dark orange, are the program required subjects. The boxes in green are the program elective subjects. And we also have the boxes in light gray. They are the general education courses. And in light blue are the departmental elective subjects. Okay, and you can see we start from the first year. The yellow boxes here are the required departmental courses that we have just introduced. And all students in the first years are mostly taking required courses. And in the first year, you can see some general courses from the university required also here. And the links with arrow here, these are the connections between courses. For example, if you start with calculus, then you can see following the link, the blue link, we can reach advanced calculus. So advanced calculus is a follow-up course. And this is actually a very classical subject in the traditional math department, which contains plenty of mathematical training and thinking. Another link from calculus will be here, okay? And we go to vector calculus. And notice that vector calculus is in dark orange. So it is a program required course. Basically, you can view vector calculus as a calculus course in higher dimension, or say multivariable calculus. And vector calculus is also a very important subject for engineering students. And let's go back to advanced calculus here. After taking advanced calculus, you can keep going, and the follow-up courses will be complex analysis, and you can keep go on. Then we can go to general analysis, and these 2 courses are actually 2 of the main ingredients for pure mathematics. Therefore, we designed them to be program required or elective subjects. And I forgot to mention here, calculus can also go to differential equation and also go to probability and statistics. So That means calculus is also a basic course before one can take differential equation and probability statistics. Alright, another path that I would like to point out is here. Starting from linear algebra, we can follow the green link. Okay, and you can see linear algebra is also one of the foundation of advanced calculus and differential equations. And you can also follow this green link and go to algebra. Okay, and algebra here, it means abstract algebra. So you can see we only require all of the students to take just one semester, and the second semester is optional. It just requires students to just require for program students to take. Okay, and you can go follow this green link, go further to cryptography. Okay, so this is actually my answer to your question. You might wonder, is there any application to abstract algebra? So cryptography is the application that we want. Okay, so what is cryptography? So it is basically, you can say it is the intersection of mathematics, the number theory, and computer science, and also electric engineering. Okay. Roughly speaking, we make use of theoretical number theory and apply it to information and security, system security. Okay, so now I would like to go back to the top, and let's look at these red links. Okay, starting from introduction to computer, you can go to mathematical software, and then you go further, we can reach computational mathematics and numerical analysis. Alright, and if you go even further, then you can go to practice of computational mathematics. So following this, our students actually learn more about scientific computing. Then mathematics is not just theoretical mathematics. The students will know how to really use computers to solve math-related questions. Next, let's look at the statistics and big data program. So for example, you can start from basic mathematics, and this can link to statistics and also probability theory, which are definitely the most basic courses in statistics area. And from statistics and probability, you can go ahead to link to design of experiments, regression analysis, and also mathematical statistics and advanced probability. Of course, probability can also link to advanced probability, or you can go further down to here, the statistical computations. And we offer some advanced courses here in the 4th year, you can see. And these are some of the practical subjects in statistics program. So like sampling, quality control, non-parametric statistics, data mining, visualization. Alright, we would like to go back to here, in here, starting from linear algebra. Linear algebra is also a basic course of regression analysis. Okay. And if you look at Introduction to Computer, you can link to Python R, Big Data Analytics. And further, you can go further down to here, data mining and visualization. And overall, you can see indeed we have a very complete course plan for statistics and big data students. The third program is the Computer Science and AI program. Let's also choose some paths to look at. Again, as we just mentioned, basic mathematics is certainly a fundamental course of a lot of subjects. And of course, just like we just see in a few moments ago, it links to probability and statistics and differential equations. But now we can also link to here the discrete mathematics. And discrete mathematics is a very basic course that one should study in order to go further to study algorithm. Okay, and then after you learn some algorithm, you can go to more advanced courses like graph algorithms and artificial intelligence. And of course, you can go ahead furthermore to learn some machine learning. And of course, these are the areas that the most uprising fields nowadays. Okay, and let's go back to here. See, the basic mathematics, like we just say, it links to probability and statistics. And this probability and statistics can go down further to reach the introduction to data science and then big data analysis. Okay. And if we look at introduction to computer to start with, of course, Introduction to Computer is certainly the most fundamental course for students major in computer science. Starting from here, you can learn a lot more about the computer, like programming language, data structure, and from here you can go down to algorithm, or you can go to network programming, database systems, or you can also take something to introduction to data science and so on, right? So then you can see here we have a lot of advanced courses here in the fourth year, and these are some very advanced courses for computer science and AI students. Alright, and from this map, you can see our courses are well designed, and in this way our students are pretty interdisciplined. They are not just focusing on one aspect. We hope that the course design can make the students touch various fields, and the students can really investigate their interest and develop their career.
For the next part of the talk, I would like to introduce our faculty members in the department and their research fields. I would like to go program by program. So let's first start with Mathematics and Scientific Computing program. There are 8 professors in this program. The first one comes the chairman of our department, the Professor Wang Muming. And Professor Wang received his mathematics PhD degree from Sun Yat-sen University in Taiwan. And his research fields are mainly focused on optimization theory, operator algebra, and classical analysis. Professor Wang is one of the main professors in our department to supervise most master students in this math program. There were also many in-service master students were guided by Professor Wang. He has devoted himself a lot to students and contribute hugely to our department. The next professor is Professor Gao Xinxin. Okay. She received her PhD degree from UCLA in the US. And her research fields are mainly on numerical analysis, graph theory, and its application to networking design. Also, she has been working on some mathematics education. So, Professor Gao received the University Outstanding Teacher Award years ago. She is actually a very, very nice and passionate teacher. Alright, so here is the next professor, Professor Chen Kai-hui. Professor Chen received his mathematics PhD degree from Yuan Christian University, our university, and his research fields are system integration, matrix analysis, and graph theory. Okay. And here is a remark that Professor Chen actually has had some collaborative projects with industry, some insurance company, for example, and their goal is to train students in digital information technology. So here is a picture showing that the Professor Chen is in the middle, and a lot of students in this project. And here is one of the managers in that corporation. Right, let's go to see the next professor, Professor Li Shinan. Professor Li received his PhD degree from National Central University, and his research fields are mainly on discrete mathematics, graph theory, and combinatorics. And Professor Li is actually a very nice person and is extremely passionate about teaching. Okay, so now let's look at the next professor, Professor Shao Peiqiang. He also received his PhD degree from National Central University, which is actually a university nearby our Zhongyuan University. And Professor Shao has his research fields focused on image and video processing. So this is abbreviated as IVP, and also some numerical analysis. And Professor Shao is actually a new faculty member to our department. He just joined us in this August, but he had already had a regular position at another university for some years, and he has already had a lot of experience guiding students. He's actually a very prominent young researcher in applied and computational mathematics. And here, Professor Shao gave us some very friendly, very accessible introduction to his research field. So let's take a look. Okay. So since image can be viewed as a vector valued function in R3, and a video can be viewed as a series of such functions. Dealing with images and videos is equivalent to dealing with functions. As a matter of fact, we can simply write down an equation to summarize like this. So basically, IVP, this field, is equal to mathematics plus computer. Okay, so it's the combination of math and computer. So IVP technology has been widely used in many research fields, such as face recognition, multimedia, streaming, license plate recognition, vehicle navigation, medical inspection, self-driving systems, virtual reality, augmented reality, metaverse, and more. Okay, so students who have undergone professional mathematics and computing training can choose different imaging application fields for future career development according to their own interests. There are a large number of job openings for IVP. I think I got it wrong. IVP, okay, IVP related algorithm engineers all over the world. Okay, so it's a very, very nice introduction to IVP, and thanks to Professor Shaw. Okay. And the next professor is Professor Lü Mingjie. Professor Lü received his PhD degree from National Jiao Tong University in Taiwan, and his research fields are dynamical system and differential equations. Okay, and Professor Lü also gave some short description about his research here. So let's see. In the last few years, Professor Lü was focusing on partial differential equations about kinetic theory of gases, including Boltzmann equation, relativistic Boltzmann equation, and also Fokker-Planck equation, and so on. His major study was on stability and long-time behavior of these equations. And recently, he wants to learn more about uncertainty quantification for kinetic theory and further make some numerical simulations of these equations. Okay, so you can see that Professor Lü's research actually also combine some mathematics and some numerical computations. Okay. All right. So now this is me. I already introduced myself a bit in the beginning. I'm Wan-Yu Tsai, and I received my PhD from University of Maryland at College Park in the U.S. And my research fields are algebra, representation theory of V groups, and some number theory. Okay, and I want to give some remark here is that V groups have been widely, actually it has been widely used in many areas, including plenty of mathematics areas such as geometry, differential equations, and so on, and as well as physics, quantum mechanics, and a lot more. They use V groups a lot. Okay, and recently I actually learned something about cryptography that then use representation series of V groups a lot. Okay, so that means although representation theory of V groups is like a very pure mathematics area, but it also has a lot of applications to cryptography. And cryptography is something related to system security, something like that. And I hope to investigate in this part more and lead students to learn more about this area. Okay. And here comes the professor Xie Tianchang. Okay, he received his mathematics PhD degree from Indiana University at Bloomington, and his research fields are mainly on calculus of variations, nonlinear partial differential equations, and their numerical computations. And Professor Xie is extremely energetic and enthusiastic professor. His research has a lot to do with physics. And I'm going to show you a video that the Professor Xie recorded for us. He introduced his research a little bit more in details. Okay, let's look at the video.
Hi everyone. I would like to give a short introduction about my research. My research is on the calculus variation and the nonlinear partial differential equation. The variational problem is that we try to minimize some energy functional in some certain function space. And I also interested in the numerical simulation for those problems. The problem I'm interested in come from various natural phenomena. For example, Ginzburg-Landau system of the superconductivity, Grove-Petesky model of the Bose-Einstein condensation. Okay, the mathematical interest of those problems is that the existence of the solution of the partial differential equation were the minimizer of the variation problem. I also interested in the regularity theory of such solution. I also want to understand the low-dimensional structure of the defect come from those models, like the interface and vertex. For the numerical simulation, if the student would like to learn those areas, I will ask them to learn some numerical method, like the numerical method for partial differential equation or numerical method for variational problem. I usually use the finite difference method to solve the problem. Sometimes use the finite element method, sometimes use the spectrum method. So I would teach my student and those methods and ask them to write the numerical code to simulate those phenomena. Okay, let me show the example. Okay, this is one example. Okay, this is a numerical simulation for the spin-one Bose-Einstein condensation. Okay, so as the times go by, you could see the phase separation occurs in the unit disk. Also, and this will we also observe this kind of phenomena in the Bose-Einstein condensation. Okay, thank you for your attention.
Okay, let's look at the next program, the Statistics and Big Data program. There are 6 professors in this program. The first one is Professor Yang Mingsheng. He is a distinguished professor. Professor Yang received his statistics PhD degree from University of South Carolina, and his research fields are mainly on fuzzy classification algorithm, image quality recognition system, neural fuzzy network. Okay, and Professor Yang is one of very few distinguished professors in our university. He is definitely an exceptional researcher, and he has had a lot of very big publications. There were several PhD students from our department under his supervision, including some foreign students. Okay, so we have next few some junior professors here. Let me introduce just a bit. So the first professor is Zheng Xiuli, Professor Zheng Xiuli. She received her PhD degree from University of Florida, and the research fields of her are nonparametric statistics, neural fuzzy network. And the next one is Professor Wu Jianhua. He received PhD from Nebraska State University, also from the US, and the research field is on biostatistics. And also the next professor, Lingyu Zhao, he received his PhD from University of Iowa, and the research fields of him are Bayesian statistics, time series analysis, stochastic process. Okay. And the next professor in statistics is Professor Wu Yuzheng. Professor Wu received his PhD, actually a mathematics PhD, from National Central University, and his research fields are mainly on survival analysis, Bayesian statistics, clinical trials statistics. Okay, and one remark here that I want to point out is that Professor Wu has been collaborating with some overseas researchers in the US. They are recruiting some students who are interested in their research area. And this may be a good opportunity for students who want to go deeper in their area in statistics. Okay. Okay, so the last professor in this program is a newcoming professor, Professor Jianli Xin. She received her PhD from National Tsinghua University, and Professor Jian has research fields on bioinformatics, biostatistics. Okay, and she is new to our department, and she's a very nice person, and I would like to introduce her more. So I asked her to record a short video for us. So please look at the following video to know more about Professor Jian. Okay.
Hi, my name is Li Xinchen. I'm the assistant professor in the Department of Applied Mathematics at Yuan Christian University. I have my PhD degree in statistics. And regarding the professional working experience, I worked in the Taiwan National Health Research Institute for around 5 years. And therefore, I have extensive research experience in bioinformatics, cancer surveillance, and biomedical data science. For the current research project, I focus on developing the absolute risk prediction model without prospective cohort data, especially the model for the rare disease. We building the model by synthesizing information from multiple data sources. And the second research project is the Bayesian genome-wide association study with survival outcome. Thank you.
Let's introduce the faculty members in the next program, Computer Science and AI program. There are 5 professors in this program. The first one is Professor Shi Qingling. He received his mathematics PhD from National Jiao Tong University, and he has a research field focused on discrete mathematics and graph theory. The next one is Professor Chen Xinxia. He received his PhD degree from University of Wisconsin at Madison in the US, and the research field of his are computer science and applied mathematics. And now let's look at the next professor, Professor Jiang Yiting. He received his CSIE PhD from National Taiwan University. So CSIE is computer science and information engineering. Okay. The research fields are artificial intelligence and machine learning. Okay. And Professor Jiang provided us a little bit more details about his research. Let's look at it. So Professor Jiang has research interests include artificial intelligence, data analysis, and security multiple component computing, especially in the domains of machine learning methods and their applications. The research problems are related to applying modern artificial intelligence methods to different data-related problems and innovative new data processing procedures for real-world problems. Okay. So thanks to Professor Jiang. So the next professor is Professor Zhang Hongrui. He also received his CSIE PhD from National Taiwan University, and the research fields of Professor Zhang are artificial intelligence, computer simulations, and data science and analysis. Okay, and also Professor Zhang was very nice with providing this very good description to us. Okay, let's take a look. Professor Zhang's research interests include artificial intelligence, computer simulations, and data analysis, especially in computer games and disease transmission simulations. The research problems are focused on algorithm design and relevant data analysis. For games-related topics, the problems are focused on the research behavior with imperfect information games. For the disease simulation systems, the problems are focused on the stochastic behavior within the transmissions. Okay, so you can see that Professor Jiang and Professor Zhang, they have some collaboration a lot, and they usually co-advise a lot of students in this program, and they treat the problems of artificial intelligence a lot. The last professor that I'm going to introduce is Professor Yu Peiduo. He received his PhD degree from City University of Hong Kong, and the research fields are on graph theory and algorithm, networking, machine learning. Professor Yu is also a very prominent young researcher in the computer science program. He used to lead students to join a competition on AI and big data and earn an award. Okay, so here let's look at a picture. The middle person is Professor Yu, and the two students that he supervised. Okay, so Professor Yu also provided us a recording talking about his research. Let's take a look.
My name is Peiduo Yu. I am an assistant professor of the Department of Applied Mathematics at Chung Christian University. My research interests lie at the intersection of data science and graph algorithms, including machine learning techniques on graph structural data.
Briefly speaking, a graph is a mathematical object consisting of nodes connected by edges. We can model different networks in the real world by graphs. For example, we can use a tree graph to model a road network that illustrates the shortest path between any two locations. Or we can model an online social network by a graph where each node is a user in the online social network, and the edges represent the relationship among users.
In my research, I develop graph algorithms that are applied to data with graph structures, mainly focusing on the application and computation of different graph centralities.
The last part of the talk, I would like to talk a little bit about the career developments. And this is to give some ideas about what the occupations could be after we get a degree. Before we talk about more introduction to the jobs that the student can look for, we would like to introduce two employment projects, the two employment programs that the university collaborates with two companies. So the two companies here are the two insurance company. So the first one is the Nanshan Life Insurance Company, and the second one is the Fubang Life Insurance Company. And for the Nanshan Life Insurance Company, let's look at it. And they require students to finish 12 credits before they can get a certificate. So the four kinds of courses are listed here. The first one is a math required course. And it is either an algebra course or a linear algebra course. And either of them is worth 3 credits. So you just need to choose one of them. And the second one is a statistics required course. So here we have 3 kinds of courses here. Statistics, mathematical statistics, and regression analysis. You just need to choose one of them to finish these 3 credits. And the third one is a professional knowledge course, which is usually a business school related course. So I believe there will be some designed course that you can choose. Okay. And the last one is a topical course, topical research course in applied mathematics. So then you can see these 4 kinds of courses is pretty much, most of them are a math course in our department. So our students benefit a lot from this format. After you get all of the credits, all of these 12 credits, you can go ahead to take a corporate internship course in their company. And that is also worth 3 credits. And that 3 credits can contribute to your academic credits. All right. And then you can go ahead to take qualifying tests before you get a certificate. And if you have a certificate, maybe it will be easier. You have a priority to get a job more easily in their company. Of course, it's not guaranteed. You just have you have a better chance. Okay. And then let's look at Fubang Life Insurance Company. This is pretty much the same, you can see. And we also have a required math course and a statistics course. And instead of some business course, here it requires 2 credit practical course, which is usually a general education course, and 1 credit for mini course offered by that corporation. And the last one is a corporate internship course that is offered by the company. All right. And all of the 12 credits, once the 12 credits is satisfied, then you can go to take a qualifying test before you get a certificate and get a better chance to get into the company. Okay, now let's look at the jobs that students can look for after they graduate. In the past, math students were more traditional. Many of them got into the education industry. So you can see here, I list a lot of jobs related to education, like education training, preschool care and education, some education administration, or a lot of different kind of teacher. Here we have elementary, high school teachers or primary school teachers, or you can get a PhD and become a university professor. Okay? But nowadays it's quite different. it's not just like education is the only way to have your career. And students also learn a lot of computers in our department, even for those students who are enrolled in math program. Okay. So our students also have the skills that allow them to be engaged in technology or other fields. So if you have the programming skills, that would be better. So here you can see we can also have some science or technology and engineering areas for students to be engaged in. Now let's look at the next program, the statistics and big data program. So for statistics people, you can see there are a lot more options. So for example, you can be engaged in finance, manufacturing, medical insurance company. They require a lot of statisticians, and also biotechnology and research development. Okay. So that means being a statistician is definitely very popular. But of course, you can also choose another way, like being an actuary and being a quality control personnel or clinical laboratory researcher. Or if you are more traditional, you can also get a PhD degree and stay in academia to become a professor in the university. That is also an option. Okay. The next program is the computer science and AI program. You can imagine in our daily life, every organization needs an IT support. If you know computers well, you don't need to worry about getting a job. But of course, major in this program is more than that. There are a variety of choices here. So for example, besides IT assistants, you can choose to be a web designer, or you can do algorithm development engineer, or some software development and programming, or you can do digital communication. And so there are a lot of choices here. I don't need to specify too much. Right. So now we would like to take a minute to look at the job status of our recent graduates. The employment rate has been as high as 95%, and 90% of them get a salary between 32,000 to 60,000 NT dollars. That is approximately between 1,000 and 2,000 USD dollars per month. And so what kind of job they are working on? So most of them are high school teachers, insurance company managers, and IT technicians or engineers. Okay. So of course there are some extreme case, very extreme good case. So some of them got very, very high salary from well-known companies such as TSMC. So TSMC is actually an internationally famous manufacturing company. All right, my talk has come to an end. So just one last thing that I would like to encourage you to keep in mind. So the more you learn, the more skills that you have, and the more options that you will have. Okay. Thank you very much for your attention.